Okay, in this lesson we'll be looking at what we call recursive rules. Previously, whether you know it or not, we've been using what's called explicit rules. We're going to learn recursive rules today, and we're going to be able to look at the difference between the two rules. And we're going to write sequences in this recursive form. So previously, we had an arithmetic sequence. And here you could see that with every hop, we're adding 4. So we can turn this into an explicit rule. We learned how to do this. We took the first term, which was 3, and then every term after that, we're adding 4 to that. And so that was our common difference, and then we multiply that times n minus 1. This is an explicit rule because if I want to find the 10th term, I plug 10 into here and I get the 10th term. If I want the 100th term, I put 100 into here, into n, and I solve and I get my 100th term. Let's look at how we dealt with geometric sequences. In this case, we did something similar. We put our initial term 4 right there, and then we notice that we have a common ratio between each of these terms of 1/2. We multiply times 1/2 to get from 4 to 2. We multiply by 1/2 to get from 2 to 1. So we can write that as 4, the initial value, times 1/2 raised to the n minus 1. And again, if I wanted to get to, say, the 10th term, I just plug that into my equation, 10 minus 1. I plug 10 into the value of n, and then I could figure this out and get a number. So we called this explicit form, where the term an is defined by, it's a function of n, the number. Okay, let's look at recursive form. In recursive form, an, the nth term, is defined by the n minus 1 term, or even beyond that, any other preceding term. So, the n here stands for the nth term. This means the term right before the an term, and then we have 2 terms before the an term and 3 terms before the nth term. So we have, it doesn't always have to be using all of these, but it's used. It's defined by a previous one, and it's not defined by n itself. Okay. So let's look at this arithmetic term, and we know that the common difference is 4. So from 15, I add 4 to get 19. From any term, I take the previous term and add 4 to that. So this is what we call our recursive rule. But we have a problem here because, say I want to find a2. a2 is equal to the previous term a1 plus 4, but what's a1? Well, a1 is equal to a0 plus 4, but what's a0? a0 is at some point we need to have an initial value. So that's why we need to, in addition to this rule up here, we also have to give a starting value. The starting value is 3 right here, and then every other term is defined by its previous term. So once we're given the initial value and we're given this rule here, we could say, okay, after every term we add 4. So we could see in this example here, the first term here, a2, is equal to a1, the previous term, plus 4. So the previous term was 3, we add 4, we get 7. And so on and so forth. The thing is, we have to iterate. To get the 4th term, I have to find the 3rd term. To find the 3rd term, I have to know the 2nd term. To find the 2nd term, I need to know the 1st term. and then I need to depend on the initial state information here. So that's why we call this recursive form, not because it's defined by previous terms. And the benefit, it's kind of a nice, concise form here. I kind of like it because it's pretty clear what's going on. It says every term I'm adding 4. But the problem with this form is, unfortunately, to get the 100th term, I need to get the 99, 98, 97, 96, etc. So in that sense, it's not as useful. Okay, now here's the geometric form. Every term I'm dividing by 2, multiplying by 1/2. So I say that the nth term, or the nth term, an, is equal to 1/2 of the term right before that. But I need to define my starting case as well. A1 is equal to the initial value of 4. So we say that, our next term is 1/2 the previous term. So again, starting from A2, it's equal to 1/2 of A1, which in this case is 1/2 times 4 because we're given the very first value being 4. And so on and so forth. We can get the 3rd term, 4th term, 5th term in that same way. We keep multiplying by 1/2. So that's basically the lesson for today. That's the recursive form. And you can go ahead and practice on these problems. We'll review it the next time we meet.